Squeeze it in here. Hey everybody, Mr. Mac here. I hope I'm not in the way. We're going to do some 1.7 practice basic constructions. You will need a compass. You will need a straight edge. You will need a pencil. Be nice to have an eraser. Look at that, sticks. Kind of. Okay, so we've looked at 4 basic constructions. Copying segments, copying angles, angle bisector, and perpendicular bisector. We're applying all those things in this practice set. Okay, so the first thing in part E, we're going to construct segment EF so that EF is 3 times the length of AB, and we're going to subtract 2CD from that. So EF is 3AB minus 2CD. Okay. Let's start off with a point. And let's call that E. So here's endpoint E. We just need to figure out where F is. So we're going to start off with a ray. And now we're going to measure AB. So I'm going to take our compass and we're going to put one point at A, and we're going to try to get the other endpoint, the lead, right at B. Let's make a little bit of an arc just to make sure. Sometimes we can open it up or close down on it, just make sure we're going right through B. Then I'm going to bring this to E here at my endpoint. I'm going to make an arc. This would be 1 AB. This length right here is the same as that. In fact, I could put a symbol right here. Congruent symbol. We know those two are congruent. Let's make another one. I'm going to walk it down to this endpoint and put another arc. And notice I'm holding it at the top of the compass and I spin it between my fingers. Alright. That's 2. Let's keep going. You can see that. I like to keep, did I go the right place? Yep. I like to keep the arcs visible. Don't erase your arcs. That's part of our work. Now, 3AB is right there. Now we're going to subtract 2 of these CDs. So let's measure CD. Alright. Now, I'm going to go from this endpoint here back to E. So I'm going to flip my compass around, find my endpoint there. Alright, that's 1 length of CD. Right there. That's 1 CD. And then this one is, oof, slip. Got this on an angle. I have the camera right behind me. It's a little awkward, but I'll get there. Right there. So let's just make sure I got my same length here. Yep. Now, just to be explicitly clear, this whole length is 3AB, and this whole length right here is 2CD. So this point right there is F. And maybe I'll just darken the line here a little bit more. But I'm not going to erase anything. I'm going to show all my work. Alright, that's E. Part F, construct segment IJ so that segment IJ is a, I think I'm missing an is here, is a perpendicular bisector for segment GH, and so that segment IJ is congruent to segment GH. Alright, here's GH. I need a perpendicular bisector. Okay, so perpendicular bisector. That means we need two arcs. I'm going to take the compass and I'm going to go past halfway. It doesn't matter how far we go, but it does matter. If we go less than halfway, we don't get intersections in our arcs. We can make it really big, but then it's just hard to fit on our paper. So anywhere between about 2/3 to a whole here is good. I'm going to go about 2/3, and I'm going to make an arc from H. Remember, an arc is just a part of a circle. I'm going to make the same arc with the same radius. Don't change anything on your adjustment here between the two arcs. And then I'm going to put my points here on the intersections. Small points. Sometimes I see people making these really big points, but then it's hard to be accurate with your line if it's so big. Just make it small and clear and sharp. And I'm going to put a line through here. So now this is a 90-degree angle right here. And this has been bisected. We've cut that into two. So we did that part. Now it says we want segment IJ to be the same length as GH, right? Congruent. It doesn't say how it's supposed to look. Just it's got to be perpendicular bisector and the same length. So how about I call this point right here I? I'm going to call that I. And now like we did in E, we're just going to measure the length G to H. Okay, and then I'm going to go to I, and I'll put an arc from I. And where that intersects, I'm going to call that, what am I making here? J. So there it is. That is my construction. And it is done. And just make it a little bit darker so we can see it. Alright, so I made, yep, I did that part too. Alright. G, construct a 135-degree angle by combining angles. Okay, we learned how to construct a 90-degree and a 60-degree. So these are very different constructions. But once we know how to do an angle, we always know how to bisect it. So we can do a 45-degree angle off the 90. We can do a 30-degree angle off the 60, and then we can do a 15-degree right off at the 30, etc. Right? So 135. Which angles here do I add to get to 135? Well, simply these two, right? It's the 90 and the 45. So if I construct a 90 and then have another 90 that I bisect, I can get 135. We know how to do a 90. Look, we did that with F. So how about we just start with a segment right here. Let's call it XY. And let's do a perpendicular bisector on this. How many arcs do we need? We're going to do a perpendicular bisector. How many arcs? 2. So we go at least halfway, if not all the way. And really don't draw this too low because you're going to go off the page, right? So I'm going to go 2/3. Looks like there's plenty of room. And here are my intersections here. And I'm going to make my line. This is my perpendicular bisector here. Now this angle right here is 90. And this angle here is 90. How about why don't we call this intersection here O. Let's call this one up here Z. How about we create a angle bisector here that cuts this 90 into half, and then I'd have a 90 and a 45. So let's do an angle bisector. How many arcs? 3. So the first arc we want to make, how about we go through Z here, maybe just to be clean. So I get that to go right through Z. First arc has to cross both sides of the angle. Right there. So it's crossing here, just before the Y, just right there, and here. There's my first arc. And really, you know, I could have made this smaller. I'll just show you. If I would have made it smaller, it's still good. I could have gone with this intersection and this one. And then we're going to open it. Say we can go back to the original measurement there if we want. Then I'm going to make arc from Y out here in this quadrant, and then an arc from Z, and then here is the bisector. We go from the vertex through this intersection, and we just cut this in half. Now I could have also used these 2 points just as a second example, and we'll see the intersection. See the intersection is going to go right through that ray too. So it goes right through there. Okay, so let's call this point W. So the measure of angle XOW is, it's going to be 90 plus 45, right? 90 plus 45 is 135 degrees. There it is. Okay, very good. Let's take a look at the next one. Masking tape is super useful to keep your paper from sliding and spinning. So you only have 2 hands, and you need a hand for your tea. Super rainy and cool today. Perfect day to do some constructions. Okay, H. Construct a 75-degree angle by combining angles. Think about what angles you know how to construct and put them together. Alright, so again, we know 90 and 45, we know 60, we know 30, we can do a 15. What could we combine here? How about a 45 and a 30 would work? A 60 and a 15 would work. I think a 16 and a 15 is a little more simple. Fewer steps. So how do we construct a 60? Well, we're going to start with a segment again. And this is the construction basically for an equilateral triangle. Equilateral triangle has all 3 sides congruent and all the angles are 60. So how about I label these points A and B. So where would C? C is going to be up here somewhere. So let's make sure I'm measuring from A to B with my compass, and I'm going to draw an arc going up. Flip it, put my point at A, draw my arc up. this intersection right here is going to be point C. And I can draw a ray up through here. And if I draw it on this, I could have drawn on this side too. If I do this side, then I get my equilateral triangle. This angle is going to be 60. Okay, now I need to add 15 to that. Let's see here. How about I can go off of this direction, or I could go down. How about we add the 15 down? Okay, so how about we do another 60-degree down, and then we'll bisect that, and then bisect that. So I'm going to work off this same length AB, and how about I draw down this arc like that. And if I come over here to B, this is just making another 60 going down. So I have a 60-degree angle going in this direction and another one coming down in this direction. And we can call this, so let's work from here. I'm going to point here and come back up to here. I'm using my pencil, make sure I'm getting an accurate drawing. And I think I'm going to run into the next problem here a little bit. That's okay. So this is 60. So let's bisect the 60. How many arcs? 3. The first arc has to cross both sides of the angle. We'll already have one there. This one's already here, so we could use that one. I could draw a new one. But how about we would just use the existing one right here and maybe call this X and Y so we see it. And now I'm going to go from X and draw an arc, and I'm going to go from Y and draw an arc and find that intersection. Boom, right there. So I've just cut this 60 in half. So this is now a 30. Let's cut the 30 in half. So how many arcs do we need for an angle bisector? 3. One to cross both sides of the angle. We already have that one. We can use this one. And then one from, let's call this Z, and one from X to find out the intersection over here. And that is Mrs. Mack calling me. Hello?
Hey,
What's up?
they don't have any full-fat free plain yogurt.
That's okay.
Is it more important to have the low-fat or more important to have the green?
It doesn't matter.
Really? It doesn't matter?
We can try it. I don't think it does. Full fat probably better.
Full-fat but plain.
That's fine.
Like,
Yeah.
not.
Mm-hmm.
Okay. Alright, thank you.
Okay. Bye.
Bye.
Mrs. Mack is asking me if she can get plain yogurt, and does it have to be the Greek kind? No, it doesn't. Making palak paneer. Good Indian dish. Check out one of my Mac News. I made that earlier in the year. Alright, so let's make an arc from B. And, actually, B or X, I named them both. I just realized that. This point right here. And one from Z. Okay, see that intersection right here? Now that is where we're going to bisect this 30 degree into a 15. There it is. So this is a 15. Let's call this D. How about we call it, do we have an E? E. So this measurement here is 75 degrees. measure of angle CAE equals 75. Sweet. All right, I think I'm getting in my own light here. I construct angle ABC so that ABC is 3.5 times the measure of angle XYZ. XYZ is right here. Okay, so we're going to do it right here. Let's see. So ABC has a vertex called B. And we know one of the sides. So let's call this ray right here, ray BA. How about that? Ray BA. Now, this is going to open up this way, in this direction. We can go counterclockwise. Could have gone clockwise if we wanted. And I want to go 3.5 times this angle. So how about we first start off with copying this angle on here first. So first thing we're going to do, we're going to copy. Thinking about the copy angle construction that we did in the basic construction. What do? First thing we do is we come over here to the angle that we want to copy, and we want to put an arc. So how about something like that? It's too big, it misses our points. It's too small, it's just hard to work with. So the important points are these right here where they intersect. Take this same arc and put it on B. And when I say same arc, same radius, I'm actually going to make it longer because we know this is going to be a bigger angle. So I'm going to make a bigger angle, so I need a bigger arc. Now, this point right here, let's call this one M1. This one over here is M2. These are in the same relative position to our starting angles here on this ray. I want to find N2. Where does N2 go on here? It's got to be the same distance away from N1 to M1. So how do I find this distance? Well, all we do is we just measure it with the compass right here. See that? Now we're going to transfer that over here and we're going to make an arc. So let's just double check that and that. So this right here is N2. Now I can draw this ray and I would have two congruent angles. But I want this one to be 3.5 times. So how do I make this one bigger? What I'm going to do is I'm just going to keep on going down this arc. I know that this length right here is 1 times this angle. If I go 2 times, all I have to do is come over here and just add another arc. So this would be double this angle. How do I get 3 times? Just keep going. 3 times. It's going to be there. 3 times. Let's go 4. Let's go 4 times the angle. Now, I don't want 4 times. I want 3.5, somewhere in between here. How can I find the middle of this arc right here? Well, one thing we can do is we could do a bisector on this arc and then measure that off of one of these ends. Or we can just bisect this angle right here. We already have arc number 1. All we have to do now is find the middle of these 2 endpoints. Lots of ways we do this. I'm just going to take my compass and make an arc out over here and then switch it over to this side, an arc over here, and I get the intersection right here. Look, I could have drawn these sides and it'd just be like we did in these previous problems. But I don't want to draw it because then it's just distracting. So I'm just going to visualize that this is the angle that I just bisected. So this is 1, 2, 3.5. So let's call this C right here. And so I did it. ABC is 3 times the measure of XYZ. And you know, I could get a protractor and check it, but we don't use protractors in constructing. And I'm very satisfied that I did this one very well. Okay, J, find the center of the given regular pentagon by making a construction. Regular pentagon. What's regular mean? It means all the sides are congruent and all the angles are congruent. So how do we find the center of this pentagon? Well, a lot of ways. We could find the angle bisectors. We could find the perpendicular bisectors. When I say angle bisectors, we can find the intersection of the angle bisectors, the intersection of the perpendicular bisectors. Let's do perpendicular bisector. How many would we need to know? There are 5 sides. We could find all 5. But what's the minimum we would need? Minimum is really 2, isn't it? But how about we do 3 so that we can check it? So how do we do a perpendicular bisector? We need 2 arcs. We need to make an arc at least halfway across from one endpoint. Flip it. Make the same radius arc on the other. And then we're going to draw our bisector, perpendicular bisector. Like that. This is perpendicular, these are congruent. Let's do it again. It's hard to do it on these sides because I didn't give you a whole lot of room. Let's go on this side right here. So, arc, flip, arc, looks like this is the intersection right there. You know how we could check it? We could do one more side. So let's do one more side right here. Arc, one endpoint, followed up with an arc on another endpoint. And I hope it goes through that point, that intersection. Big money, no whammies. It does. Boom. There's the center. Find the center. Let's call it C. Alright, if we did these other 2, it would work. By the way, if we did the angle bisectors, the lines are going to be coming from the vertex instead of the midpoint, but it's still going to work. Would still work. Alright. I hope my camera battery is doing okay, because I can't see what's going on. Alright, so as it turns out, I did run out of battery, so I get to redo these last few with you. Alright, find the center of the circle by making a construction. Okay, so what we can do with this circle is we can put a few points on here. Let's go X, Y, and Z. And I'm going to, at least I don't have to do the whole thing. It was just the last page. Man, when I saw that it was not recorded, I was not happy. But it's alright. Sometimes you gotta redo stuff. happens in life. So I made a triangle with the vertices on the circle. So what are we going to do to these sides, do you think? Well, we're going to make perpendicular bisectors. Perpendicular bisectors will actually find the center of the circle, and then when you do it for a triangle, it actually tells you the place where you could draw a circle that circumscribes the triangle. If we were to do angle bisectors, they would be over here somewhere, and it wouldn't work to find the circle like we were looking for. But it would tell us where the center would be of a circle that's inscribed. We'll learn more about that later. It's on the horizon. So perpendicular bisectors, let's make them. We need to go at least halfway for each segment. So let's go there and there. That is a perpendicular bisector. Hope I'm not in the way of the camera. And then let's scoot over a little bit. Let's do another perpendicular bisector on YZ. Okay, my posture is terrible here. I'll lay flat here for a little bit when I'm done with this video. Alright, so I have a point here and here where the arcs intersect above and below the segment, and line it up there. This is the perpendicular bisector here. So it looks like here's our intersection here. We can do this last perpendicular bisector on XZ just as a check more than anything else. And goes right through there. So here is our center C, right there. Whew. Oh, stretch out. All right, next. Construct a triangle with angles 30, 45, and 105. All right, the sum of a triangle is 180. Okay, that is a fact in geometry. So if I can construct the 30 and the 45 part, the 105 will be automatic, or I could start with the 105 and the 45 and the 30 would be automatic. We could do 105. That would be, for instance, a 90 plus a 15. That could give us 105. We know how to do a 90, and a 15 is based off of a 60-degree angle. How about we do a 30 and a 45? Let's start with a 45. How do we get a 45? Start with a 90. How do we do a 90? We need to make, so let's make this a little bit longer. Let's choose 2 points on here. Let's call it X and Y. And let's do a perpendicular bisector on XY. How many arcs do we need for a perpendicular bisector? I wish I had $5 for every time I said perpendicular bisector today. Perpendicular bisector. 2 arcs. One from one endpoint, flip it, same radius. Other endpoint, we need to get intersections above and below. Don't just do above or below. You gotta do 2. You need 2 intersections here. 2 points for a line. So this is our 90. We need to cut it in two congruent pieces to get a 45. So I'm going to make an arc from this upper right hand quadrant. It needs to intersect both sides of my angle, and it does right here and right here. That's arc number 1. Arc number 2, I need to draw from this intersection out into space here, this intersection out into there, that intersects, and I would draw a ray from our vertex here through that intersection. Okay, that is 45. Now, let's make the 30-degree angle over here somewhere coming back. So I already have this point Y. How about we put a point Z over here? The 30 is based off the 60. So the construction that gives us an equilateral triangle. So how do we do that? We measure the length from Z to Y here, and we make an arc going up, flip it, go from Y, arc going up, this intersection right here, draw a line from Z through this point, and here's my 60. Now if I had given you a problem that said construct a triangle with angles 45, 60, and 75, because 45 plus 60 plus 75 would give us 180, we would just intersect it here and we'd be done. But we need this to be 30. So we have to cut the 60 in half. How many arcs for an angle bisector? 3. 1 to intersect both sides of the angle. So that gives us intersection there and there. And then an arc from each intersection that intersect each other. Just drop my pencil. Okay, so let's do an arc from this intersection and an arc from this one. Oh, it's tricky. There's a lot going on here. Let's see. So we got, it's here, right there. And so now we've just bisected this. So this is now 30. 45, 30, this is going to be 105. Looks slightly obtuse. And there it is. This triangle right here. Leave the arcs. Shows your work. And we could check this with a protractor, but we don't. I don't need to, because I know I just constructed it perfectly. Okay, I hope that one recorded this time. I'll see you guys.